Now we need to broaden the conversation beyond just hyperactivity and attention, because emerging research suggests artificial food colorings might have more extensive effects on neurodevelopment than we've been discussing. And I want to be clear up front that this is an area where the science is still developing, but the early signals are concerning enough to warrant precautionary action. Most of the public discussion around food dyes focuses on immediate behavioral effects, the hyperactivity and attention problems that show up in short-term challenge studies. But child development doesn't happen in neat, isolated compartments. Neurodevelopmental researchers I've consulted emphasize that the brain systems involved in attention, impulse control, emotional regulation, sleep, learning, and mood are all interconnected and developing simultaneously during childhood. If artificial colors are affecting one of these systems, it's entirely plausible they're affecting others. Longitudinal studies that follow children over years rather than just hours or days are starting to reveal these broader patterns. Some cohort analyses have found associations between higher dietary intake of artificial colors in early childhood and not just attention problems, but also sleep disturbances, mood dysregulation, and even subtle effects on learning and academic performance. These are correlational findings, so we can't say definitively that the dyes cause these outcomes, but the associations persist even after controlling for obvious confounders like sugar intake, screen time, socioeconomic factors, and so on. Animal models provide some mechanistic insights that are honestly pretty troubling. Studies in rodents have shown that chronic exposure to certain artificial colors during critical developmental windows can alter neurotransmitter systems, affect neuronal structure, and produce lasting behavioral changes that persist into adulthood. Now, you can't directly translate rodent studies to human children, but these findings raise serious questions about what we might be doing to millions of developing brains. The mechanistic studies suggest these petroleum-derived chemicals may interfere with dopamine and other neurotransmitter systems that are crucial for learning, motivation, and emotional regulation. Sleep is an area that's particularly understudied, but potentially important. Several parents who've removed artificial colors from their children's diets report improvements in sleep quality and ease of falling asleep, even though they weren't initially focused on sleep as an issue. There's some theoretical basis for this. If these additives are affecting arousal systems in the brain, you'd expect to see effects on sleep-wake regulation. Cognitive testing in some developmental cohorts has found small but measurable differences in processing speed and working memory associated with dietary patterns high in artificial additives. Again, these are preliminary findings that need replication, but they're pointing in a consistent direction. Neuroscientists emphasize that we're looking at subtle effects, not catastrophic brain damage, but subtle effects distributed across millions of children add up to a significant public health burden. The developmental timeline is crucial here. The human brain develops rapidly from conception through adolescence, with particularly critical windows in early childhood when basic neural architecture is being established. Exposing developing brains to chemicals that might interfere with this process, even subtly, is a gamble we don't need to take. The precautionary principle suggests that when you have reasonable evidence of potential harm, especially to vulnerable populations like children, and when safer alternatives exist, you should choose the safer option. We don't need to wait for absolute proof of long-term neurodevelopmental damage to justify removing unnecessary chemicals from kids' food. The research gaps are real. We need more longitudinal studies with better exposure assessment, more mechanistic work to understand how these chemicals interact with developing neural systems, more investigation of potential long-term effects. But while we're waiting for that research, millions of children are consuming these additives every single day. That seems backward to me. We should be erring on the side of caution, especially when we're talking about developing brains and when alternatives exist.